But if kz is minus z something, then this exponential term would be exponential plus something z. That means the sound pressure in z direction is exponentially increased. Is very interesting. That violate conservation of energy is accepted. Disregard the physically unacceptable solution. Okay? So that motivated us to analyze or to explore the physical meaning that has this equality graphically. Okay, let's see what does it mean by graphically. So that gave us famous plot the propagation characteristics in wave number domain. Okay? So in Kx, what does it mean if I have Kx equals 0 and Ky equals 0? What does it mean? That means Kx represents 2 pi over lambda x. So Kx 0 means that I have lambda infinitely large. That means that I have infinite large plate vibrating. Right? What does it mean? And Ky is also infinitely large. Okay, let's reserve that interesting physical situation for your own sake. What does it mean over here? That means the plate in x direction, that is this direction, vibrate with this amplitude. But in this direction, wavelength is straight line. That means wavelength is infinity, right? Okay, that certainly give us a hint. What does it mean? That means that there's no wave in either x and y direction. Therefore, there's no wave is generated. Okay, this point, I have this kind of wave. Right? And at this point, I have wave in this direction. This point, I have wave like this. Okay? This point, I have a wave like this. Okay? And so on, so on. Okay. Then I can imagine there is a certain circle that is k square equal to kx square plus ky square. Right? Right? Because this is kx and ky, then this equation make this circle. Okay? This region is when k square is smaller or large? Smaller. So that is the case. K square is smaller than right? Then what happened? Evanescent wave. Is it right? Is it right? Yes. Strange. It's large. Huh? Yeah, it is large. Yeah, put the number, for example. 0, 0, for example. 0, 0. Then K square should be large, right? Okay. So this is the reason smaller, and this is the reason where we have evanescent wave, and this is the reason where we have a propagating wave, and this circle we call it radiation circle. Okay? All right? Okay. Now, suppose you have measurement plane and you measure sound on this plane. That means you are measuring P, X, Y. Right? For the given frequency omega. So denote that I measure pressure on certain frequency omega. Say I whistle 1 kilohertz frequency, and you are measuring sound at this point. That is what this expression implies. Okay? And then you convert this to wave number domain. Meaning that you are taking Fourier transform with respect to x and the Fourier transform with respect to y twice. That is wave number domain expression of this sound at this frequency. Suppose you are measuring pxy and transferring, and then you multiply that with right? Then what you will obtain? You obtain P double hat Kx, Ky, Kz. And then you back Fourier transform it. Then what you will have? And say, then you can obtain the sound distribution on any z. Any z. In this case, z was 0. And by just multiplying k to the z and z, then you will obtain the sound pressure distribution on unmeasured z.